Hello, Aslam class. This is your maths lesson on the 7th of January. I'm just going to get the screen up so that you can see today's slides. Okay, the first slide is your arithmetic that would have been for today. So what you need to do, as always, because it's multiplication of your 12 times tables today, I would like you to pause the video, get yourself a little timer or a stopwatch, and time yourself quickly answering these questions as quickly as you can. So pause the video and good luck. Okay, now that we've gone through that, just go quickly through the answers with you for your arithmetic. So listen carefully. 4 times 12 is 48. 3 times 12 is 36. 9 times 12 is 108. 10 times 12 is 120. 0 times 12 is 0. 8 times 12 is 96. 2 times 12 is 24. 11 times 12 is 132. 6 times 12 is 72. And 7 times 12 is 84. So well done if you got all of them correct. Okay, today we're going to be looking at finding factor pairs. You may not have heard the term factor before, so we're going to go through that to begin with. Now, factors are numbers, basically, that when we multiply two factors together, we get a multiple, okay? And factors are, and multiples will have factors that go with them as well. So for example, if I can just clear this up, let's take multiplication of 4 multiplied by 5, and of course that gives us 20. If we were to break this down now, 20 is what we call a multiple. It is a multiple of 4 and 5, because when we times 4 and 5 together, we get 20. These two numbers here, 4 and 5, we call them factors. These are factors of 20 because they go into 20 as a whole number. And a factor pairs are pairs of numbers that when you multiply them together, they give you a multiple. So 20 factors of 20 are 4 and 5. There are also more factors of 20 because 2 can, if we do 2 times 10, they are factor pairs, and 2 times 10 also gives us 20. So a number can have more than just one set of factor pairs. Now, if we have a look at the screen here, we can see which factor pairs for 16 do these arrays show. Okay, so similar to what I've just done here, showing you that numbers do have more than just one set of factors. So in this first array here, we've got 16 dots in a line, okay? So that shows us 1 times 16, okay? If we have a look at this array here, we've got we've got 8 yellow dots going across, and then we've got another 8 going below. So what multiplication or what factor pairs are making up 16 here? If you said 2 times 8, you would be correct. I don't know why that's moved both. And then the last one here in the red, we've got 4 rows and 4 columns of red dots. And there we have the factor pair of 4 times. So can you think, before we move on to the next slide, are there any other factors of 16 other than 1, 2, 4, 8, and 16? And how can you prove that you found all of them? That's the question that I'm asking you. So pause the video and have a little think about that. Now, we can use factor spiders, okay, to help us find out what the factors are for certain numbers. And you can see here in our factor spider over here, we put in our 18 in the middle. We're then trying to find factor pairs, so numbers that we times together to give us 18. So we have a look. 1. What do we times 1 by to make 18? We do 1 multiplied by 18. So 1 times 18 gives us 18. So that's one factor pair there. Within 2, what do we times by 2 to give us 18? 2 times 9 will give us 18. And then our last factor pair here, what do we times 3 by to give us 18? 3 times 6. Okay, and then on the other side here, you can see a factor spider for 20. So 20 is our multiple that we've got in our spider. And then we have to think of what numbers do we times together to give us 20, or what factor pairs do we times together? So 1, we times 1 by 20 to give us 20. We can times 2 by 10 to give us 20. And we can also multiply 4 by 5 to give us 20. Notice we haven't got 3 there, because 3, when we go through the 3 times table, 3 times 6 is 18, and then 3 times 7 gives us 21. So 3 is not a factor of 20. So remember, factors are numbers that when we times them together, they give us a multiple. And they have to be whole numbers as well. So what I would like you to do now is to pause the video and draw factor spiders for the numbers 11, 14, and then 26. So pause the video and good luck with them. And once you've finished, you can unpause the video and I'll go through the answers. Okay, so we're going to draw a factor spider first for number 11. So I'm going to put my 11 in the middle, and I'm going to think to myself, okay, what numbers do I times together to give me 11? Well, I know that 1 and 11, if I times them 2 numbers together, I get 11. Yeah, 1 times 11 is 11. Brilliant. Okay, what about the next number? Let's think of 2. Now, when I think of 2, 2 times something, it's not going to give me 11. Okay, because if I go through the 2 times table, it goes 2, 4, 6, 8, 10, 12. That goes above 11, so therefore I can't times anything by 2 to give me 11. 3, if I go through the 3 times table, 3, 6, 9, 12. Again, it doesn't go to 11. What about the 4 times table? 4, 8, 12. No, that's not hitting 11 either. 5 times table, 5, 10, 15. No, that's not 11. 6 times table, 6, 12. Now, any number above 2 times 7 is 14, so it's always going to be above 11. So therefore, there are no more factor pairs for 11. When you have a number where its factor pairs are 1 and the number itself, this number we call a prime number. So a prime number is a number where it only has factor pairs of 1 and itself, okay? No other factor pairs, okay? It's only got them factor pairs. So 13 is similar as well, because 13, you can only times 1 and 13 to give you 13. So they're the only factor pairs for 13. So 13 is also a prime number. Can you think of any other prime numbers you can think of? Okay, so let's now do 14. Okay, the easy one is obviously 1 and 14. Now, what do we times 2 by to give us 14? We times it by 7, okay? So this has got another factor pair, 2 and 7. 3, if we try and times a number by 3, the closest we get to 14 is 3 times 5, which is 15. 4 times 4 will give us 16, not 14. So again, there are no more other factor pairs for number 14. Okay, so we've got 1 times 4 and 2 and 7. So these are all factors of 14. And then our last one is 26. Okay, so we've got 1, we've got 26. What do we times 2 by to give us 26? It's 13. Okay, is 26 in the 3 times table? No, it's not. Is it in the 4 times table? No, it's not. Is it in the 5s? No, and it's not in the 6. So these are the only factor pairs for 26. 1, 26, 2, and 13. So well done if you've got them all correct. Now for this next slide, you need to complete the missing numbers. Okay, so the number 40 has how many factor pairs do you think, or factors? And then the factors of 40 are what? And then can you write down the factor pairs? You can, if you want to, use a spider, factor spider, to help you with this, okay? And to answer that first question, you may need to figure out what the factors of 40 are. So pause the video and give it a go. Okay, now you've unpaused the video and given it a go. Let's see how well you've done. So the factors of 40, I'm going to find out what the factors of 40 are first. So I know that 1 and 40, because 1 times 40 is 40. I know that 20 and 2 are factors of 40. I also know that 4 and 10 are factors of 40. And I also know that 5 and 8 are factors of 40. I don't think there are any more. So I count up how many I've got. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 factors that the number 40 has. The factors of 40 are 1, 20, 4, 5, 8, 10, 2, 40. You probably want to put them in numerical order. So we would say they are 1, 2, 4, 5, 8, 10, 20, and 40. Oh, the wrong one. And then the factor pairs are 1 and 40, 20 and 2, 4 and 10, and 5 and 8. And how do you know when to stop hunting for factors? Pause the video. Okay, so do you know how to stop hunting for factors? It's when you go above, when you start multiplying the numbers and you go above that number 40, you know that you can't do any more. Or you try to divide it by as many numbers as you can to give whole numbers. So well done if you got them ones correct. Now, what you need to do is for the following is list the factors for each of the numbers. And again, you can use a spider factor if you would like. You don't have to. You may be able to list it. Use your times tables facts. Pause the video, and then we'll go through the answers. Okay, so well done for doing that work. Hopefully you've done you found that okay. So the factors of 35 are the following: 1, 5, 7, and 35. 49 is 1, 7, and 49. The factors of 52 are 1, 2, 4, 13, 26, and 52. The factors of 46 are 1, 2, 23, and 46. And the factors of 60, they have lots: 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, and 60 itself. So well done if you got them correct. Okay, your independent work for today then, guys, is the following. Question number 1. Alex is making arrays using counters. Which calculation is represented in each array? And so look for the factor pairs there. B, use your answers from part A to help you write all the factors of 18. So good luck. Number 2, which is the spiders over here. Complete the factor bugs or the factor spiders for 45 and 64. You can always go back to the video to see how we've done that. Question 3, find all factor pairs for the number 72. And then for a challenge, there is a word problem. Class 4B is having a sports day. There are 36 children in the class. The children need to be in equal groups. What group sizes are possible? So there's going to be more than one answer there. So good luck with your questions. And like I say, any problems, don't hesitate to leave a message on Teams. And we will be going through this lesson in our next Maths and English live video. So good luck. And I'll see you in the next video. Bye-bye.